This is TWiT.
Fast prototyping, though, you're going to have to explain to me what that means.
Well, this is something that every maker, every DIYer should know how to do, and that is to take something that you kind of want to do. Maybe you don't quite have an idea exactly of what it is, or what you want to do, or how to get there, and then do the steps, the logic tree that you need to get from point A to point Z or double Z. That's the idea of fast prototyping. And it's enabled by the fact that we have things like Arduinos and 3D printers where I can do a lot of iterations of a project to get to my finished product.
So fast prototyping is not what I do, which is go to the dollar store for my Halloween decorations.
Actually, it is. And this is why I wanted to wrap in your dollar store decorations, because there are so many things that makers will do that start with something they saw. You know, it might be, oh, you know what, I saw a skull in a dollar store. I would love to be able to move the jaw, or I'd like to be able to illuminate it, or I'd like to be able to make it turn on a pivot. Well, from that initial thing that you might buy, maybe you cut it up, maybe you redesign it, maybe you print it entirely from a 3D print, but it's all part of that process of turning an idea into something that's real, which I love. I mean, that's what know-how is all about, that fast prototyping, that maker spirit of, I'm going to take something and make it into something else.
I love it.
Are you down with that?
I'm down with that.
Okay. So this is what we're going to do. Burke, if you cut to the side view, this is Skully, but this is the fast prototype of Skully. So essentially, this is a super simple project. This is not much different from the mad science bubbler that we did with Jason Howell a few weeks ago. This is just a 3D printed skull. This is a deck that's also been 3D printed. All the electronics are inside of there. Now, I've done a couple of design things, which we'll go over in just a little bit. Things like the runes and the Celtic marks across, just to give it a little extra something. But ultimately, what this is going to do is it's going to use a WS2812 ring of LEDs combined with an Arduino and combined with this. This thing poking out of the front is an ultrasonic distance sensor. So the idea is this goes over a candy bowl, and as kids reach for the candy, you're going to be able to change the animation patterns, even doing something like that deep, menacing red, which is, super geeky. Now, the nice thing about this is if you have the printer and you have the filament, this project is, like less than $10. It's a very inexpensive way for you to get into the Halloween spirit.
Nice.
Yeah. Let's take a look at what we're going to need for Project Skully. We already know that we're going to be using these. Now this, I cannot take, I would love to take credit for this, but I cannot, because this was actually a 3D scan of a dollar store skull. It's actually, they call it a Celtic skull. If you go to the side view there, Burke, you can see that it's got a bunch of patterns. So it's not just, put this next to a traditional skull. No, go to the side view. Stay on the side view. This is our traditional skull. This is our small Celtic skull. Now the reason why I made it so small is for reasons. It just takes a long time to print. Even at this size, this is like a 16-hour print. And I just didn't have time to fast prototype. I've only got 2 printers, and I needed to make 2 complete sets. Ideally, I would make this bigger, and it's really easy to scale this thing up or down. But you'll notice it kind of has a melted look. That's not actually part of the design. This, Megan, it's called support. So when I create something like this, a 3D print like Skully, what's going to happen is you end up with a lot of overhangs. In fact, let's bring fully assembled Skully up here. All these overhangs, this poses a problem for a 3D printer because remember, it's printing from the bottom up. And these surfaces here, there's nothing underneath it. So when it goes to print that, it would just fall. The filament would just fall all the way down, right? So to counter that, when I slice this, the program puts in all of this stuff, which is technically, theoretically, very easally removed, which you're going to do.
Okay.
Yeah, I'm going to...
I knew I had a purpose here.
You got a job here, and it's going to take a while. But, all right, so that's the skull. We're going to fast prototype this into something like this. Now, let's go ahead and go over the parts list. I'm giving the parts for the entire thing. The reason why we're not going to complete the project today is because the sensors I got for this actually are horrible. They're terrible. They're incredibly inaccurate, entirely up to me. That was my fault. I bought cheap sensors for like 76 cents each. I probably should have paid $1.80 more, and then I would have gotten proper sensors. But the parts list is not too great. The first thing we're going to start with is a 16 LED ring. Go ahead and go to the overhead, Burke. The overhead, not the side, there you go. So this is what this looks like. You've seen these before. We've used this in the Project Steampunk goggles very easily. They're WS2812 LEDs which we're going to explain to you if you've never watched Know How before, that allow me to individually control every LED. So I can change the color and the brightness of all the LEDs in this chain using this. These little pads allow me to daisy chain these units together. So I have power, and for power I need ground and 5 volts, and then I have, you'll see, in and out. That's data in and data out. That one wire will carry the information to the LEDs and tell them what to do. And I'll explain how these work in just a bit. So that's one thing I need. The second thing I'm going to need is an Arduino Nano. We've seen these before. I'm using a Nano, again, because I like the size format. I could use a full size. If I have an Uno, that would actually fit in the base. But I'm using a Nano just because I really, really like the smaller size. It really lends itself to being pushed into tight spaces. Then this, and unfortunately this is the part that's busted on my current iteration of Skully, is an there we go, an HCSR04 ultrasonic module. Now this is super simple. It's an echolocation. So this is going to go ahead and send out an ultrasonic pulse, which hits an object, bounces back, and is received on this side. That's trigger and that's receiver. And by taking that time and dividing it by 2 and then multiplying it by the speed of sound, I know how far away something is, right? And that just tells me if something's getting closer or something's getting further away. So these 3 parts are what I need for Project Skully in its entirety. Now I've disabled the ultrasonic sensor on this particular project because it's flaky. Unfortunately, again, low quality parts.
You should have gone to the dollar store, not the 79-cent store.
Touche. I've got nothing for that one. You're right. I got cheap. Every once in a while, being cheap does bite you. No, actually, I was lulled into a sense of false security because I bought these about 3 years ago. I bought a pack of 20 of them, and the first 5 or 6 were perfect, and then I unwrapped the rest of them, and they're all bad.
Oh.
So, oops. Either that or they just sat too long. Maybe they've got a shelf life. Yeah. Yeah, actually, let's go. I made sure that links are all in the show notes. So you're going to need this. Go ahead and go to that first link. The 16 LED WS2812. It's a 50/50 LED ring. It's going to cost you about $4. However, if you do a lot of these projects and you're willing to buy them in like a pack of 10, you can get that price down to about $250. And again, I always buy in bulk because I use a lot of these parts and I don't like to order them right as I'm beginning a project because it takes a long time to get here. Second part, if you go and go, is the Arduino Nano. And again, I would absolutely suggest that you buy this in bulk because it's close to $3 if you buy them individually. If you buy them in like a pack of 10 or even 20, you can get that price down to about $1.80. And these are not cheap. These are not the cheap versions. These are actually good ones that just sold in bulk. Okay. And then, of course, you're going to need that ultrasonic sensor, which Brooke already showed you. That thing's going to run you about $1.60, $2 if you buy the right one. Don't be like me and go to eBay and buy a bunch of cheap ones because now I just have a bunch of junk. Yeah, sorry about that. Okay, other parts that you're going to need. Screws. Now you can use any screws that you want. The reason why I didn't include this in the primary list is a lot of you are going to have screws, M3 screws from previous projects. I bought this from Banggood. If you go ahead and go to that link, Burke. I like this. It's a 240 sort of a multiples bin. It's going to cost you about $7. You probably have some M3 screws around, so if you don't want them, just use the ones that you've got. But I kind of like these because they're black, they're anodized, they last a long time, and there's varying lengths. You're also going to need about, I don't know, a foot or 2 of 30 gauge silicone wire. And the reason why I use silicone wire is because if you feel this, Megan, this is what regular, like plastic-coated wire feels like, and that's what silicone wire feels like.
Yeah, much better.
Much better, much more flexible. It doesn't tend to crack as it gets older, and it also survives temperature. So when I'm soldering, if I'm using silicone wire, what will happen is it will do nothing. It only affects the wire. If I'm using plastic wire, if I put too much heat, the insulation actually starts melting, and then I get fumes, and that's a bad thing. Yeah, don't do that. So that's the individual pieces that you're going to need. As I said before, you're looking at, what? Maybe $2, $3 for the LED ring, maybe $2 for the Arduino Nano, maybe about $2 for the ultrasonic sensor. That's, what, $8? Plus, maybe you have to buy a batch of screws for $9 or $7. So really, this is a very inexpensive Halloween project.